Alright, Section 13, Protective Devices, EMD Maintenance Manual for a 645. Section 13, Protective Devices, Low Oil Pressure Shutdown, Differential Water Crankcase Pressure Detector, Description Maintenance Overspeed, Trip Description Maintenance Adjusting Spring Tension, Hot Oil Shutdown Service Data Specification Equipment List. Alright, protective devices. General, the section contains the description maintenance of the information for the engine protective devices. The devices are designed to shut the engine in the event of the malfunction occurring during the engine. Low oil pressure shutdown pressure description. Low oil pressure shutdown plunger. Figure 11. Figure 13.1 is part of the low oil pressure shutdown device, which is contained in the governor. Although its protective device is not necessarily an accessory to the engine, refer to the section 12 description maintenance of the low oil pressure shutdown device. 13.1 should low oil pressure shutdown plunger. Your differential water crankcase pressure detector assembly, the combination differential water crankcase pressure detector. 13.2, the mechanically operated pressure sensitive devices determine the abnormal condition of the engine cooling system of the crankcase pressure. This potentially harmful condition exists for the protective devices which will cause engine shutdown. 13.2 show the differential water crankcase pressure detector installation, reset buttons, vent and test elbow, and the test cock. The water pressure portion of the detector balances the differential pressure of the water pump output of the water pump input against the air box pressure of the hold on the oil relief valve with the latch position. When the differential pressure across the water pump becomes less than the air box pressure, figure 13.3, the diagram moves causing the oil drain valve to open and dump the engine oil with the low oil sensing device in the governor. The governor senses the low oil pressure initiates the low oil shutdown. Bleed holes are provided between the pump inlet and outlet diaphragms. The pump inlet and the air box diaphragms are visually indicated with a leak. The device provides protection against water pump cavitation, which results in a low coolant level with excessive cooling temperature, exhaust gases, cooling system, several other cooling system failures. The water portion of the detector will trip whenever the cooling system is drained. To latch the water portion of the engine must be running and the cooling system vented. Figure 13.3 shows low differential water pressure conditions. The crankcase pressure portion of the device consists of the oil relief valve comparable to one of the water portion latch position. Positive pressure built up with the crankcase oil relief valve with releasing lube oil pressure to the engine governor is relieved. Figure 13.4 as the water portion of the governor senses low oil pressure initiates the engine shutdown. 13.4 shows the positive crank pressure control pressure condition. Warning, the following engine shutdown because the engine pressure detector has been adequate. Do not open any handhold top deck covers to make inspection until the engine has stopped, allowed to cool off for at least 2 hours. Do not attempt to restart the engine until the cause of the trip has been determined to correct with the action pressure detector indicate the possibility of the condition within the engine, such as the overheated bearing, the main ignition of the main ignite of the hot oil vapors of the explosive force. Air is allowed to enter for the crankcase pressure. A detector cannot be reset due to the operating your engine until the detector has replaced it, since the diagram plate backup plate may be damaged. Alright, your maintenance. The differential water and crankcase pressure detector should be tested periodically to ensure proper operation. Test valve installed with the water pump outlet in the line. Water safety portion provides a means manual dumping of the water pressure on the diagram. In turn, provides checking on the tripping action water detector by rotating the test valve handle hole horizontal position. Discharge for the coolant for the small orifice of the hole. Valve should be checked steadily flow because of the contaminants from the coolant in the small orifice. Valve may be plugged, reducing the restriction, bleeding off the pressure of the diaphragm. In most cases, the rapidly opening and closing testing valve a few times, dislodging obstruction, allow the water detector to trip, plunging the test valve into no way. Normal pressure, and then it shows test valve position. Affect the operation water device while the engine is idle speed with operating the test valve opening the free flow of the coolant and it should trip the device on the first or second try. If the device does not trip the device, should be taken out of the check and the test and manually determine the cause of the malfunction. It is recommended that the operation of the water detector check monthly with the test valve. The test valve handle must be returned in vertical position, figure 13.5, before starting engine to the test the crankcase pressure portion of the starting engine, the hydrometer bulb, to create suction on the vent elbow that should trip the resets of the stem as in simulates positive pressure being applied with the opposite side of the diaphragm. Caution, diaphragm could be damaged applying with the positive pressure through the vent valve tube of the exhaust air of the bulb before testing. Alright, if the test is unsatisfactory, repeat the test. If the detector should not trip, replay for the detector. Pressure of the detector can also be detected. It's tested by hand-operated vacuum pump. Connect the vacuum pump to the T of the line between the valve, vent and elbow of the water manometer to operate the pump slowly with the detector trip. Reset with the detector. Repeat the procedure, checking the manometer with the tripping pressure set with each service device limits. Alright, your overspeed trip mechanism. The overspeed mechanism provides with the safety of the feature for the stop the injection of fuel into the cylinder should the engine speed becomes excessive. Shown with the mechanical overspeed tripling mechanism, the engine speed should increase the specified limit. The overspeed mechanism will shut down the engine. A trip shaft exceed the length of the engine bank of the camshaft will provide with a cam each of the cylinder. When the rotated contact spring loaded with a catch pawl mounted on each cylinder head, located directly under the injector rocker arm. If the overspeed trip housing in the front of the engine trip shaft is connected with the spring-operated link, the lever mechanism resets the lever of the trip lock shaft when the pulling down on the right bank puts tension on them. So what you see is your overspeed protection. You see the trip pawl and trip lock. Your camshaft, your trip shaft, lock and cam injector, and then your camshaft, trip lock, and trip pawl. And the actuating spring and the counter camshaft weights. And then you have the rocker arm rocker, injection rocker arm, adjusting trip position, latch position. Alright, adjusting spring with the tension being held with the trip of the pawl with the engine notching of the trip locking lever shaft. This is the normal running position in which the cams on the trip shaft they are held away from the rocker arms cam and catch pawls. The overspeed trip release mechanism incorporated with the right bank of the camshaft counterweight that consists of the flyweight held with the adjustable tension spring with the end speed. End speed exceed the set of the limit of the tension of the spring overcoming the central figure force acting on the flyweight, causing the flyweight to move outward over the contact with the trip pawl. This allows the actuating spring the acting of the connection links to rotate the trip shaft with the consequent of the trip shaft cams contact raise the injector rocker arm pawls, preventing the full injector rocker arm roller contact on its cam to prevent the fuel injection with the stop the engine. Upon resetting the counterclockwise movement of the reset lever, the trip shall be cams release the injector rocker arm catches the rotation of the camshaft, starting the engine lifting rocker arm slightly, allowing the catch pawl to resume unlatched position, releasing the injector rocker arms from the normal operation. Figure 13.7 shows the reset lever to latch and tripped. Maintenance drain sleeve removal. Lubricating oil from the overspeed tripping housing drain is top of the necessary area, avoiding accessory drive housing with a two removable cast aluminum drain valve. Figure 13.8. Each sleeve has two rubber oil ring seals. Either oil leakage detected between the housing of the sleeve should be removed and the oil rings replaced as follows. So 13.8 shows your overspeed tripping housing drain sleeves, drain sleeve, retainer, drain sleeve, and seals. Move the overspeed tripping housing, cover the bar over the engine with a counterweight position with the top of the engine. Remove the bolt and the steel retainer strip of the figure 13.8 holding sleeve. Use a suitable pry bar with the strip of the under sleeve of the handle. Carefully remove the sleeve of the housing. Remove the sleeve and the clean sleeves. Install seal marked on the red dot with the upper groove of the sleeve with the unmarked seal with the lower groove. Apply the film on the on seal sleeve and install the sleeve and the retainer strap. Adjusting mechanical overspeed trip. The adjusting of the overspeed with the shutting engine down. Remove the cover of the right side of the overspeed trip housing. Turn the adjusting nut. Figure 13.9. Increase the decrease the spring tension as required. Decrease the engine speed at which overspeed trips rates operate. Increase spring tension. Figure 13.9 shows the overspeed tripping adjusting nut. After adjusting, the nut has been returned. Lock nut may be tightened. The engine run to test speed with the trip operates. The speed rises on the engine from the idle trip should be not made from rise the engine from the idle trip should be made 20 to 30 seconds. Several adjustments may require the final setting of the tripping speed is reached. Alright, your hot oil shutdown device figure 13.10 consists of the thermostatic valve associated with the piping. The valve is located with the discharge elbow. The lube oil pump with the piping. The valve is connected with the oil pressure is between differential water and crankcase pressure detector of the governor. There is also a drain line piping with the valve of the governor drive housing. When oil temperature is 255 to 260 degrees, 260 degrees, the thermostatic valve will open and pressure for the oil is allowed to pass through the valve, draining it into the governor driving housing. The governor, since the resistant low oil pressure, initiates the engine shutdown. Maintenance thermostatic valves should be removed and tested at intervals specified applicable to scheduled maintenance program. And then it goes into service data protective valves and specifications. And this was your Section 13 protective devices. Electric Motive Division GM engine maintenance manuals for the 645 Section 13 protective devices. Testing.